Okay, well, we're gonna go ahead and get started here. I just first of all want to say hello and welcome. This is our very first All Things Integration meetup, and I'm absolutely excited just to really kick this off. Just to introduce myself, my name is Stephanie Lawrence. I'm the Marketing Event Coordinator at Big Compass. But really, before we jump into the topic at hand, I do want to introduce Big Compass and our involvement within this meetup. So first of all, Big Compass is all about building connections in a disconnected world, wanting everything intertwined from people to systems and companies. We feel like the more connected a world, the better the world is. So we thought we'd kind of kick off and create our own meetup focusing on all things integration. For today, the topic is going to be Serverless Cloud Integrations, presented by Cloud Practice Manager Aaron Lieberman.
This is our first All Things Integration meetup, and we want to get to know everyone in the integration space in those respective cities that Stephanie was talking about, and just get to know what's out there. We want to learn what you're doing. We want you to learn what we're doing, and just learn from each other and help to bring the community together. You know, like Stephanie said, we're helping to build connections in a disconnected world. And so one of the slices of integrations that we're going to talk about, which is the focus of today's presentation, is Serverless Cloud Integrations, which I'm very excited for, being the Cloud Practice Manager. And so what we'll actually talk about today is, why are we talking about serverless in the first place? What are some industry trends? And then we're going to balance out the benefits of serverless with some serverless blind spots. And I think it's really important to balance those two out, because the benefits of serverless are vast and immense, but you really have to look out for some common serverless blind spots in real world practical implementations. And then we're going to look at use cases for serverless, and we'll demo a salient use case that we have come up with here at Big Compass. And then finally, we'll talk about quickly migrating to the cloud. And real quick, just about me, Stephanie sort of already introduced me. I am the Cloud Practice Manager here at Big Compass. I'm also a cloud architect. I'm AWS certified developer and solution architect, as well as a few other technologies like MuleSoft. And I've been around the integration space, actually starting in Web Methods and MuleSoft, and most recently for about the past 5 years now with AWS. And so anything related to, integrations or combining technologies like MuleSoft and AWS into an integration solution, I'm happy to talk about. Don't hesitate to reach out to me. You can find me on LinkedIn, or my email is aaron@bigcompass.com. I am also part organizer with Stephanie. You can reach out to me via Meetup, the Meetup platform as well. Big Compass, we're a boutique IT consulting firm specializing in integrations. You're going to hear integrations a lot today. This is the All Things Integration Meetup, so we always want to put everything that we're talking about in the context of integrations and related technologies. So that might be the Web Methods and the MuleSofts and the Boomies of the world. It might also mean delivering a serverless integration on AWS. That's a custom integration. And what we really specialize in is excelling and combining those technologies and bringing an unbiased approach to delivering the right solution for our clients. And we build connections. We build connections between systems and apps and corporations, and most importantly, people. I think without the connections between people, we wouldn't have much in this world. And I think it's especially important right now in the midst of COVID, while we're all socially distancing. And our primary focus for our clients is delivering integration as a competitive advantage.
Right.
And heard a little noise there. If you could stay on mute, that would be great. Thank you. So our primary focus is delivering integration as a competitive advantage. And now we get the opportunity to share integration success stories with the community here through this meetup. And that's exactly what we're striving for. So you'll see events being posted using this meetup platform, and we want to talk about some of these 6 pillars of integration as a competitive advantage and different technologies and solutions within each pillar. And today we're here to talk about cloud and serverless integrations and how that can accelerate your integration and therefore accelerate innovation. But also don't hesitate to reach out. Like I said, if you would like to present on any one of these pillars, any particular solution within each one of these pillars, anything along the lines of APIs or different technologies like the MuleSofts of the world, will be fair game for this meetup. And we are more than willing and open to hearing those presentations and collaborating with you on those future presentations. All right, so let's get into it. What's out there in the industry right now? So for legacy and iPaaS solutions that are sitting on-prem, 84% of those on-premise servers are over-provisioned. That's 84%. Almost all on-premise servers are over-provisioned, to put it another way. And due to the nature of on-premise servers, you're almost forced to over-provision those servers. It's actually a smart move to over-provision those servers because you want the wiggle room within those servers to be able to scale up if needed. And it's very difficult to right-size your servers based on traffic or trying to predict future needs. So you don't want to come up against the point where a bottleneck is created due to the capacity of your on-prem servers. So you can run up against scaling bottlenecks and overpriced resources due to this increasing your total cost of ownership to maintain that system. And this is exactly why so many organizations are looking to move to the cloud. They don't have to be locked into physical capacity in the cloud, whereas in a data center, you are locked into physical capacity. And you can set up your foundation on a platform in the cloud where you can innovate quickly, scale effortlessly, and drive competitive advantage. And so we're here to talk about serverless, and it's just one slice of how businesses can use integration as a competitive advantage, like I just talked about. And serverless is hot right now. It excites me. It excites a lot of people, hopefully you as well, since you're joining this meetup. And outside of just being exciting though, it helps power integration as a competitive advantage. It can lower your cost and increase reliability. And if you get your deployment cycle right, you can rapidly produce flexible, scalable solutions quicker than ever before. And you can also innovate quickly and create integrations at a pace faster than ever before. So as serverless integrations relates back to integrations, I think it's really about accelerating potential, accelerating opportunity, accelerating growth. And you can also stay ahead of technological trends. Your workloads are only becoming more diverse. I think everyone can agree to that. There's only increasing traffic and more systems talking to each other and becoming more unpredictable as the diversity of processes increases. And so you're opening yourself up to the serverless cloud. It really opens you up to the innovation of AWS. If you think about it, you don't even know how you're going to use that in the future. But hooking into AWS's platform allows you to take advantage of the continuing innovation and service development and features that AWS produces constantly. So AWS might produce 100 different services, each year. I'm exaggerating, but you get to take advantage of those 100 different services if AWS is coming out with those each year. So serverless is relatively new, and I want to give you the common benefits and pitfalls of serverless so you can understand fully the value that serverless can provide, but like any technology, it has its downside. And so we'll discuss that downside and those common pitfalls and some mitigation techniques that go along with those common pitfalls so you can deliver a serverless solution more effectively. So let's talk about the benefits. So here's the things that you can derive a lot of value out of a service architecture for your integrations, and I want to help you understand the real world benefits. So number one is scalability. By default in AWS, you can spin up to 1,000 concurrent Lambdas, and you can only go up from there if you put in requests to AWS. It's really almost infinitely limitless. And serverless doesn't just scale up, it scales down too. This is a major benefit for workloads that you don't need to keep always on. And that's extremely common in many integration scenarios. We'll talk about scaling up and down in use cases here in just a minute. Benefit number two is high availability. The wonderful thing about serverless services is that they're highly available out of the box. And with integration platforms needing to get as close to 100% SLAs these days as humanly possible, this allows you to pass on these great SLAs to the clients who integrate with your system. And I would just throw a warning out there to be careful of VPCs, especially with AWS Lambdas, which can work against you as it relates to high availability. And if you're curious about that, again, feel free to reach out to me. Benefit number three would be security. Security of serverless services in AWS is controlled primarily by IAM, Identity and Access Management. So make sure your IAM roles are solid and you'll essentially be inherently secure. Of course, if you're exposing Lambdas behind an API though, you're gonna have to make sure your API is secure. But it's only those scenarios that you actually have to worry about security. And so these first three benefits really allow an organization to focus on development rather than worrying about implementing the right architecture for scaling. You still have to think about scaling and high availability and security, but it's only for certain scenarios. Like one that I mentioned is exposing APIs. Another that I mentioned is if you have to put your Lambda in a VPC. It's only in those specific scenarios that you have to actually think about this stuff. Otherwise, you can just focus on feature development, which leads to more rapid innovation. So benefit number 4 then is skill sets. And like I said earlier, serverless is hot and it excites a lot of people. And if you're looking for serverless talent, it's there. Big Compass has it. I'm sure most of you here have serverless talent. It's out there. And one of the other great benefits is that serverless is relatively language agnostic, which I love. Some companies decide to code their AWS Lambdas in Java. Some decide to code their Lambdas in Node.js, and so on and so forth. You can be relatively language agnostic, which is a huge benefit in finding talented people to actually code your serverless integrations. And other serverless services are codeless, actually. So if you think about things like SQS or SNS on AWS, it's actually codeless. All it takes is getting into the AWS console and performing a few clicks, unless you're using something like Terraform or CloudFormation, which makes it easy and repeatable to deploy those types of assets. Benefit number 5 would be cost. Big Compass has helped some of our customers save over 90% in ongoing costs by moving their integration platform to the serverless cloud in AWS. That's over 90%. So, CIOs love that. They love seeing this reduced operational expenditure by over 90% in some cases. Of course, that's going to be balanced with an upfront implementation cost, but your ongoing cost can be drastically decreased. And this is one of the main results of the scalability aspect here. So first, it's very cheap to run serverless services, and you're implementing this pay-as-you-go model for the most part. And for example, the first 1 million requests in AWS Lambda are free per month. And second, scaling down is a huge win, as I said. When serverless is off, you're typically not getting charged for it. So you don't need an always-on solution and can take advantage of that pay-as-you-go model. And then benefit number 6 is innovation. So all of these benefits up until this one kind of spur innovation, right? Serverless allows you to focus on rapid feature development rather than the minutia of network security and VMs and virtualization and so on and so forth. So you simply develop within your barriers, within your great DevOps processes, and you check in code and you deploy and you stay focused just on that rather than worrying about many of the other things that come with the legacy application. So it allows you to build out this more rich feature set by accelerating your growth. So let's balance that now with some serverless blind spots. And the benefits of serverless, I truly believe, can catapult a business into the stratosphere for all of the reasons I just mentioned. But some of these pitfalls is what I've seen from my real world experience, because it's not always a seamless dreamland of development and rapid deployments and everything is just golden. You run into obstacles along the way, as with any technology. So I want to say first, before diving into these pitfalls, that I think most of these can be mitigated with a mindset shift. So if you're coming from maybe a legacy monolithic type world, your mindset shift might be that there's no infrastructure to manage. And there's concurrency and parallel processing everywhere in the serverless world. And then it's a pay-as-you-go model and so on and so forth. So as you shift your mindset, you're going to start to think about some of these concepts in a slightly different way. So serverless blind spot number 1 is cold starts. And if you're not familiar with cold starts can occur on AWS Lambda. And it's a really dreaded problem to have, especially when you need a rapid response from your Lambda or API gateway. And cold starts are a result of the Lambda still running on AWS's infrastructure. And when it goes to sleep for too long, it needs to load back into memory to actually run the function. So somewhere behind the scenes, this Lambda function is actually getting loaded onto a server somewhere. It's not serverless to AWS, right? But it is serverless to us, the user. So the larger the function and the more complicated the VPC networking, the worse the cold start can actually be. So mitigation technique would be to keep your functions small or as small as possible. And by best practice, don't put your Lambda in a VPC unless absolutely necessary. That VPC can not only affect high availability, it can make these cold starts even worse. So there's also pre-warming techniques that you can employ here. If you search for pre-warming techniques, there's some pretty good techniques out there on the internet. And so you can be mindful of these things for cold starts when you need really, really low latency. Governance is serverless blind spot number 2. So everyone loves microservices, and as you create more serverless microservices, your governance over these can quickly expand and explode if you are not ready for it. And I've seen many thousands of AWS Lambdas developed in a single account, and you can imagine it can get quickly out of hand without the right governance system. So planning is absolutely key here. Create dashboards, create monitoring services, create great DevOps processes, and automate using CI/CD. And practice maintaining serverless hygiene. And I would emphasize, I believe that when you're going to stand up a serverless integration solution, that DevOps has to come hand in hand with serverless. I believe this is the #1 mitigation technique so that your governance doesn't get out of hand with serverless. If you have great DevOps processes and you have automation using CI/CD under your DevOps processes, you can mitigate many obstacles of what some today's organizations are facing and standing up, sometimes thousands of AWS Lambdas. Visibility is blind spot number 3. The mindset shift of using many parallel processing functions and distributed microservices is absolutely a game changer for the visibility of blind spot. So without planning to see into your serverless services, it can quickly get out of hand to support. Kind of goes along with that governance piece. So imagine that thousands of Lambdas are developed and working well, but the minute you have an error, you need to be able to find that error quickly and determine exactly what function that error occurred in and where in that function it occurred. So of course, no integration platform is complete without good supportability. So mitigate this blind spot with a well-designed, centralized, externalized logging and monitoring system. So you might think about something, maybe it's within AWS like X-Ray or RDS even, or it could be externalized to something like Splunk or other external systems. And parallel processing is the next blind spot. Again, I'll mention the mindset shift to parallel processing functions and distributed microservices is absolutely king in the serverless world. So scaling on demand is actually a double-edged sword if you think about it. So on the one hand, it allows you to process very, very quickly and be able to scale almost infinitely. But on the other hand, what that means is that out-of-order delivery could easily become an issue in your system, and flooding a downstream system could also become an issue now as you have many concurrently processing Lambdas. And these are 2 very common integration patterns that become non-trivial in the serverless world. So you may need to actually throttle back a Ferrari in the cases that you need order delivery, or have a system that's sending requests that can't handle the load. And it happens all the time. So you might use a stage for order delivery to be able to actually determine if your objects that you're eventing through your platform are coming out in order. You might also have to throttle back. You can do that via AWS Lambda, or maybe by slapping a queue in front of a Lambda like SQS. And the next blind spot is duplicate detection. So this blind spot bites almost everyone. It's bitten me before, and it can be a silent killer. And it can be a silent killer because this can easily slip through QA testing. A lot of times you don't have the capabilities to actually test a duplicate in QA. And if you're not aware of this, this can come to bite you in production, which is some of the worst fear for all of us, as developers and architects and API practitioners and so on and so forth. So an upstream system integrating with your system can produce a duplicate, or a duplicate can actually be produced within AWS. So for example, with SQS, due to the distributed architecture, it can actually produce a duplicate when a server behind the scenes that powers SQS goes offline. And then when it comes back online, it can contain that same message and produce a duplicate message. So you have to be able to account for duplicate detection in your serverless services. And this is just something you want to plan for no matter what kind of serverless implementation you're standing up. And to do this, you can maintain a ledger of the events that have gone through your system and check against that ledger and for any event coming to your platform. And I would just caution, make sure that ledger that I'm calling it is easily accessible and fast. Because if you're processing a lot of events through a platform, you want to be able to say that your duplicate detection system is not the bottleneck in your system, right? You want to make sure that your duplicate detection system is very, very fast. And then blind spot, the last blind spot is use the right tool for the job. And I can't emphasize this one enough. So it might sound like I'm getting hyped up or even selling serverless services. I'm not. I truly believe that there are times when you want to fit a square peg into a round hole. And there's certain times and certain use cases where serverless just doesn't make sense. Serverless is great because you can code for virtually any use case if you want to, but that can also lead down, some dark holes that you don't want to go down. So there's use cases out there where combining serverless with the right tool for the job makes sense. And I strongly believe in hybrid solutions. And we'll talk about some of those good use cases here in just a minute. So you might be thinking, after all that, is serverless right for me? And don't worry too much because, as I was sort of alluding to there, I think using the right tool for the job is so important. And many times what that means is that hybrid is actually your right approach, where maybe you're combining an iPaaS solution with your serverless implementation, and you use each one of those to its strengths. So even if you're using a legacy system right now and looking to migrate to the serverless cloud, you still might look at the right candidates for serverless and move to the cloud chunk by chunk. And we'll talk about that later in this presentation. But don't worry about making the leap to the serverless cloud 100%. I would recommend to take it in iterations because it can be a large lift. And so serverless could be your primary approach, but augmentation and the hybrid approach is expected. And so let me take a look at the chat here. It's a good, before we dive into use cases, it's a good break point. No questions, so I'm gonna keep moving. I would just reiterate, if there are any questions, don't hesitate to put them in the chat. We're gonna get a bit more technical here after use cases are done and then get into the demo. So I'll be looking at the chat here in just a few minutes again to answer any questions. So use cases, again, I think it's very important not to fit a square peg into a round hole. And I think these use cases, and I'll actually talk about some anti-use cases as well, help us take an unbiased approach on if serverless is really the right tool for us. So one good use case for serverless, and I see this one absolutely all the time, is within your system, you get a huge burst of messages or requests due to events occurring at specific points in the day. So you get these traffic bursts throughout the day. And your current servers, if you're handling this today, are beefed up and over provisioned to be able to handle these large bursts. And this can result in slowdowns and bottlenecks or large costs due to a high capacity server. And what's more, you're paying a lot to maintain these large bursts and handle those large bursts when your system is sitting idle for the majority of the time. So you maybe only get 4 large bursts of traffic throughout the day, and really your system is only on for maybe an hour out of the day, but with an always on solution, you're having to pay for that constantly. But with serverless, you can invoke your processing layer from incoming messages that scale out to thousands of currently processing AWS Lambdas, and that allows you to, number one, process faster, number two, handle those bursts with ease. You can absorb that workload really, really easily. And best of all, you can use your assets more efficiently. Now that cost for traffic bursts has drastically decreased. And those Lambdas might only be awake for an hour out of the day, like I said, and then you're only getting charged for 1 hour out of the day, or you might even be within the free tier of AWS. So great use case or serverless is traffic bursts. Number two is sporadic workloads. This might look somewhat similar to traffic bursts, but this would be along the lines of a very common integration pattern, which is low to medium volume business processes. And maybe we have a mid-volume business process that reconciles invoices when a customer makes the request. And most of the day, again, your process might be off, but on demand, we need to be able to reconcile these invoices against what was actually paid. And today, again, you might have a server that's always on to handle this request. But with serverless, you're taking advantage of being able to scale out and being able to scale back in. And the beauty of auto scaling is not just that ability to scale out, you're scaling back in. Again, for most of the day here, you're only taking those on-demand, sporadic requests. So with serverless, you can invoke that processing layer at any time. Otherwise, it's dormant, and that allows you to use your assets more efficiently and process very quickly. So again, you might only have your Lambdas on for maybe an hour out of the day, depending on these sporadic workloads. I love this use case because I'm seeing this use case in the industry more and more, and I would love to hear from the audience, if you're seeing this out there as well. But we're seeing serverless being used to extend the life of a legacy system, and I love it for this use case because it makes complete sense. You might not want to lift and shift your legacy system to the serverless cloud or anywhere for that matter in the near future, but you want to be able to extend the life of that legacy system because it works today. And all you need to do is be able to maybe stand up a control point in front of your legacy system. And that's exactly what we're seeing out there in the industry. So many times what I see work really well there is putting an API gateway in front of that legacy system to handle the control and the security and reliability and those customer-facing discoverable endpoints that can abstract your legacy system. So the public serverless API can now be extremely flexible and open up the way in which you expose your legacy system. It can also hold requests based on SLAs with clients to throttle them back so that your legacy system is not flooded as well if you're reaching some scaling bottlenecks on your legacy system. So it can be used as a control access point. Your cloud providers give you great API management, like with AWS API Gateway, you can quickly slap on security rules, you can IP whitelist, provision access, provision API keys, and so on and so forth. So again, opening yourself up to the serverless cloud opens you up to the rapid innovation of AWS. And now you've combined that great tool set from AWS with your legacy system. The last, I'm going to call this a super use case almost, because the last use case is APIs, and this really brings a few of the use cases that I just mentioned together. And I think APIs are a great culmination of those use cases because APIs these days, the use cases for them are almost limitless. I think we all probably use APIs here today. And you might have a customer-facing API that helps to get you order information and process orders when clients make requests to your API. The more you onboard clients that consume that API, the more diversity of traffic you have on this API, and the more you need to prepare for reliability and scalability of that API. And so now the great thing with API Gateway and Amazon is out of the box, it can handle 10,000 requests per second. And it allows for throttling if limits are exceeded for reliability purposes. And behind that, what's even better is API Gateway can now invoke thousands of concurrently processing AWS Lambdas to be able to process those orders or get your order information. And so you don't have to think about how these services like API Gateway and Lambda scale out. They'll do it for you. It's built into the platform, which is such a great benefit. And ultimately, instead of you having to scale up your servers, you just don't have to worry about it with the pay-as-you-go model. Maybe at night you don't process any orders. And again, you're going to take advantage of that scaling in and you're going to save a whole lot of costs. So APIs is a great use case for absorbing workload with serverless implementations. So let's talk about some anti-use cases. And I think this would be a warning from me where, again, I would say don't fit a square peg into a round hole and look to see if you're developing complexity with your serverless implementation that seems unnecessary. And if it does, you probably are. You're probably using the wrong tool for the job. And a great example of this is when you need to continuously pull an external queue, like a JMS queue for messages. So let's say you need to maintain an open connection to a JMS queue that's outside of AWS. And each time a new message lands in that queue, you can process the message. And essentially what you do in serverless is you would create, you can create that using a serverless solution, that I would say, but you would code in serverless basically for an always on solution. And I wouldn't say that it's a bad solution. It's just that another tool might be better for the job because it might be able to maintain that open connection to whatever queuing system you're using, rather than putting that extra logic into an AWS Lambda to code for that always on solution. And then another serverless warning or anti-use case, another great example would be massive data enrichment and transformation. And a great example of this is, let's say that a file, you have an inbound endpoint for your integrations and a file comes in via FTP. And that file is 5 gigabytes in size. It's really, really large. Well, AWS Lambda memory max is 3 gigabytes. And so you're limited by that capability to scale up in Lambda because it's not really what it's used for. It's meant more to be a microservice. So, very concise, smaller memory type functions. And you could develop, again, a more complex architecture to split the file before processing it in Lambda. But then once you get there, you don't have an out-of-the-box transformation utility. So you would have to come up with an elegant way now to transform this file and then batch it up again after all of the concurrently processing Lambdas have processed that file. So it's not a bad solution. It's just that another tool might be better for the job because there's tools out there that are specific to large file handling and tools out there that are specific to transforming and enriching files. And so you might take a look at, in this scenario, combining one of those tools like an iPaaS with serverless. Okay, so we're going to start to talk about the use case that we set up for our demo today. And we're going to talk about how we implemented some of those use cases that I just talked about. And the project that we put in effect for the demo, and it's actually working for us internally, is that we had the ability to sync Salesforce.com data with the target system. And in this case, that target system is a relational database table in AWS RDS. And we see this use case, we did this because we see this use case coming up a lot more with the rise of Salesforce.com. And companies want to be able to use the data that's locked up in Salesforce elsewhere in their ecosystem. And so one of the things that we're seeing is pumping that data, getting it out of Salesforce into some sort of database or external system so that you can now start to get value out of the information that was originally in Salesforce, now in a database, and maybe you can put APIs now on top of that database. So we stood up a 100% serverless system besides the target here, really the source and the target, Salesforce and RDS. But in between, it's a 100% serverless system to be able to accomplish this. So don't worry too much. There's a lot on the screen here. I'm going to walk you through it here from left to right. So on the left-hand side of the screen, we have producers and source systems. And what I mean here is that we set up, I'm going to call it a framework. What this framework allows us to do is pump in Salesforce data. It allows us to pump in data from Amazon RDS or really any producer. We're going to call this the producer side of the house. And any producer can actually event through this system as long as we have rules set up for it. We're sort of looking at an integration system here, or an integration platform that can start to route based on the events coming through it and route them to the desired target. And again, we're going to talk here about routing Salesforce data to Amazon RDS. And so that's one of our producers in this case. And the second layer here is the gateway layer. We're calling this gateway and abstraction. So there's sort of two inbound endpoints that we set up here. One is Amazon API Gateway. And so anything external that can speak over RESTful means, we're going to point to this Amazon API Gateway. What we might also have the ability to do is anything internal. So let's just say anything internal to Big Compass who can reach out directly to our Amazon SQS queue can put messages directly on the queue. And that's all the API gateway does anyway. All it does is proxy any post requests coming into the API gateway to actually land on this queue. And then from there, we can process those messages that land on that queue. So everything runs through the queue anyway. And the third layer that we have here, we're calling it receive and persist, because one of the main things that we do here is we receive that event. We create a unique transaction ID. Just speaking about best practices and serverless integrations, you want to create a transaction ID to be able to track your event all the way through the system. And we persist that event out to AWS S3. And so we have that, resilient, durable storage solution in S3. So it'll always be saved there if we need to reference or replay this particular message. And then we also do duplicate detection. If you look at the bottom of the screen, and I mentioned duplicate detection as one of the serverless blind spots, we're doing duplicate detection actually in two places here. And I'll talk about how we're doing duplicate detection in just a couple of slides, but we're doing duplicate detection here. Number one, just in case one of our producers produces a duplicate. And then I'll talk about why we're doing duplicate detection again in just a second. But our fourth layer here now is our routing layer. And we have a bunch of AWS SNS topics set up to be able to do our routing. So we can easily hook in subscribers to certain events based on the events that are coming through our platform. So what's great about these topics is you can have X number of subscribers to, let's just say, any Salesforce event that comes through the system. And moving to the right-hand side of the screen, we now have a process event layer. So on the other side of the topic, on the subscription side of the topic, we now do something similar. We get the payload that was stored in S3 earlier on in the system, and we do duplicate detection again. And we do duplicate detection again here because what I said earlier was that a producer can produce a duplicate, and we have to plan for that, but AWS can also produce a duplicate. So even if we detected a duplicate on the left-hand side of the screen, we could still get a duplicate on the right-hand side of the screen when we're actually processing the event. So we detect the duplicate that could be produced by AWS here on this layer of the system. And then in processing the event, the ultimate goal of this is to actually send the communication out to the target. And in this case, we're looking at sending information from Salesforce to AWS RDS. And that is our target system. So again, here with the target systems, similar to the producers, our target systems could be RDS, it could be Salesforce. If we want to go back from RDS and have that sync with Salesforce, we could have the bidirectional sync there, and now we need interchangeable target systems. It could also be some other destination. So maybe you want to sync Salesforce.com with MailChimp for email campaigns. It could be another target system as well. And you can start to see now the layers of this platform are allowing us to hook in different connectors, hook in, are we going to Salesforce? Are we going to RDS? Are we going to some other API that allows us to communicate via RESTful means? Or maybe it's even an FTP drop on the target side. And I want to focus now on the right-hand side of the screen. So we did all of that, like I said, because when we're getting all that data out of Salesforce and into a database, now what we can do is put an API gateway on top of that table. And now that API gateway can control access to that data. That's one of the benefits that I mentioned earlier on, is that this API gateway can now support almost any workload. And now mobile clients and desktop clients and other system-to-system connections can access this data that we've landed in this AWS RDS table. So you can start to see now how syncing Salesforce with these external systems can create huge benefit for us, because we can hook in our downstream applications to that data. And a couple things that I didn't even mention along the way was security and logging and error handling and configurations that we used along the way, and order delivery. And so those were some of the things that I talked about earlier on in the presentation. I'm not going to get so much in detail here, but if you want to talk about any one of those things, they're all built into this platform, and I'm happy to talk about that more with you. Again, feel free to just reach out. So let's talk about duplicate detection, because I will demo duplicate detection so we can look at exactly how we implemented that. And so within the Lambda, how we're doing this is we have a duplicate detection service built into the Lambdas that need to detect duplicates. And we're doing it at 2 points in our system, as I said. And so what happens in this duplicate detection service is we're running a hash generation service, and we save that hash in Dynamo. And now there's some magic that happens here, that if you think about the way that we're syncing data, so Salesforce can sync data with an AWS RDS table, but that same table can now also sync data back to salesforce.com. And so when you think about that, some of the trickery that we had to do here was that Salesforce is eventing out through our platform in one way, it's XML in this case, and RDS is eventing back to the platform in JSON. It's a completely different format. And so what you have to do there is, based on some configuration here, we're plucking out the key values of the payload to be able to generate this hash in the same way every time. And if that confused you a little bit, again, feel free to reach out. This is something that we've implemented quite a few times by this point, and it's just something you have to think about. And essentially, you want the key identifiers from any one of the interfaces running through your integration platform to be able to run this duplicate detection service, so you generate that hash and look up if there's a duplicate the same way every time. So that's the hash generation service, and you will save that hash out to Dynamo. And what Dynamo has built in that's really, really nice is that if you save that out to Dynamo and you get a success, you know that it's not a duplicate. Because what Dynamo has built in is that you can configure a filter when you're saving to Dynamo, and you can say, did I get an error due to the hash already being present in Dynamo? And if I did, then I know I got a duplicate. But if I didn't, I just know that something happened in my connectivity to Dynamo, and all I'm going to do there on the middle path is log a warning and return success to actually continue processing, because we decided, at least for this platform, that if we can't actually reach out to Dynamo in this case, we don't want to actually stop processing. In some cases, maybe a duplicate is so business critical that you wouldn't want to move on without doing duplicate detection. But in our case, it wasn't business critical. All right, so let's demo that. And so I'm going to pull up here Salesforce. Take a quick drink of water. And before I do that, any questions? Just a reminder, feel free to put questions in the chat. Don't see any questions, so I'm going to keep moving on. I'll take a look at the chat a couple more times throughout the demo here. So I'm going to pull up, you know what, I'm actually going to start with some code. I'm going to start with some code. And so there's just a couple of things that I want to show, and we're calling this the Salesforce syncing engine. That's SSE here. And what we did was, if you're not familiar with Node.js, we built this engine using Node.js and those serverless services that I showed in the diagrams on the presentation. And the first thing you're going to notice here is that we have just some nice scripts stood up with Node.js. And so we can deploy really at the push of a button. We can build, we can test, decrypt, encrypt, and we are using serverless, and that's serverless with a capital S as well. And serverless with a capital S, the serverless framework, for those of you that are familiar with it, helps us deploy all of those serverless services to AWS. So, I can do things like yarn test, and yarn test will execute our just framework here to give me a layout of the test coverage that I have for this framework. And so I'm going to just let that run in the background as I sort of move on here. And we see that it's already done, and we're doing pretty good on test coverage here, on unit test coverage. The next thing that I want to show is our serverless setup. Again, if anyone's curious about this stuff, feel free to reach out, and happy to assist or even provide templates for serverless. This is going to look pretty similar to CloudFormation, if you're familiar with CloudFormation. But what serverless is really great for standing up those serverless services and being able to deploy them at the click of a button. And what we're doing here is we're standing up everything from those SQS queues to the SNS topics to the AWS Lambdas and the API gateway itself. And all that's done just in configuration here in our serverless YAML. And we also have this built, integrated with a CI/CD mechanism on AWS. And all we're doing in our CI/CD build is we're running these commands here. So you can see that we're installing some dependencies, we're decrypting some information, just using some serverless best practices, which I'll show in a second, and then we're deploying. And deployment uses that serverless framework to deploy all of those assets for when we check in features to this framework. And so it becomes really, really easy. And one of the things that I had talked about in that presentation was governance. And so now we've kind of defined some of these great DevOps processes. So all we have to worry about now as developers or consumers of this platform is checking in features, and then the rest is handled for us. So I would strongly suggest, creating those good DevOps processes and your CI/CD automation up front before it can get out of hand. And so next thing I'll show here is just an encrypted file. Not much, right? But we're using serverless best practice or serverless implementation best practices here to be able to store some sensitive information. And this is only decrypted at build time, at deploy time. And so what we do is during our deployment process, we have keys stored in AWS that allows us to decrypt this information. And other than that, when it's checked into GitHub or what have you, it's not going to be in plain text. So next, the demo I'm going to show now is a real world scenario where we're looking at changes to a contact in Salesforce.com. And changes to a contact will event out through our platform and land in AWS RDS. And actually, again, real quick before I do that, what I'm going to do is just show you our table. This is our contacts table. Again, Salesforce is pumping this information to this RDS table. And I'm just going to query the table, and we're going to look at the last record here. Oops, let me do that again. The last record here is, I'm just changing the assistant name, you're going to notice. So the last record here is test 14, and maybe I'll change this back to Alexa. Let's just say Alexa has gotten so smart that she is now my full-time assistant and has so many capabilities that she's helping me on my day-to-day work. So I'm going to go ahead and save that. And what we're going to notice here, first of all, in DynamoDB, if I refresh this, we're going to see a new hash generated here. And by default, we have a time to live on this particular record here in DynamoDB. So this record just flowed through our system. And what this time to live is doing is it's saying, okay, Dynamo, go ahead and delete this record automatically without us having to do anything in 1 hour. And what that's really nice for is with a traditional database, you have to come up with an archiving solution, right? But in Dynamo, if you use this time to live feature, you can have these records drop off automatically and have your database table stay really, really clean. So we're going to see this dedupe hash come up again in just a second. But what we're going to see is that now the latest record for Aaron Lieberman, his assistant is now Alexa. And let's look at some timestamps on that record. So we're going to see last modified at 23:55:00. And event received at, which is when this actually landed in the database, is at 23:55:06. So this only took, despite all those components in our serverless integration framework, despite all those queues and SNS topics and lambdas and so on and so forth, this only took 6 seconds to actually flow from Salesforce, event out, and land in the database itself. And so we're looking now at the speed of serverless. We're seeing that in effect, and we're seeing that it really provides us with near real-time updates on our database when we make those updates from Salesforce. And so what I'm going to do is I'm going to copy this last modified at. I'm going to drag in Postman here. And I'm going to demo duplicate detection and how we do that. So what I'm doing here really fast is I'm just making a quick configuration to mock that we would also be syncing a change back from the database to Salesforce now. So instead of going from Salesforce to the database, we're going change in database back to Salesforce. But what I did here is that I didn't change anything. I used the exact same object that I just made the Salesforce update with, and I used the same last modified at, and we're using this last modified at for part of our duplicate detection. And so what this is going to do is it's going to say, okay, this is actually a change that came out of the database unintentionally. You know, this might have been a duplicate that was produced by a system that we just don't want to process because it's the exact same event that we just processed. So I'm going to go ahead and send this in, and we're going to get a success message here, and that's okay. You know, this has been accepted into the platform, but what we're actually going to see now getting into the Lambda itself that processes this, if I look at the latest log here, is that I got a duplicate event detected. And this was detected, you know, a couple seconds ago. And this hash here, if you notice this hash beginning in 7FC, we see that same exact hash here in Dynamo. So once that got inserted from my first event, now we have that hash to reference. We generated that hash, even though it was a different object, in the exact same way coming back from the database to Salesforce, and we recognize that as a duplicate event. And so that's really cool. All we can do there essentially is just throw an exception, and then we can stop processing. In our case, we're throwing an exception. You might throw a warning, you know, whatever you want to log there. And then we just stop processing. And that's really the meat of it. For your business, you don't want to process duplicates, right? So you want to throw them out. And in our case, we decided to log an exception there. And I'm looking for that exception. If anyone's familiar with CloudWatch Insights, you can look that CloudWatch Insights is really, really powerful that you can search through CloudWatch log streams, right? And all I'm doing is looking for that particular exception. And when I'm running this type of query, what we're seeing, I'm just going to run this in the last day, you know, you can start to get a graphical view of all of those duplicates that now have come through your system, and in a pretty quick way. And so now you can see I've had 2, 4, 6, 8, 10, 12 duplicates in the last day, in the last 24 hours here, and just testing out this platform. So another great way, if you're logging to CloudWatch as your primary mechanism, to be able to extract some value out of those logs in CloudWatch. So any questions or comments on the demo? That's the extent of the demo. And then I was going to finish out with how you can actually migrate to the serverless cloud quickly, and that'll be the extent of today's meetup. So I'm looking at the chat here. Any questions or comments? Okay. Like I said, if you have anything kind of obscure, you know, out of the ordinary, don't hesitate to reach out. I'm more than happy to talk about it. All right. So last part of the presentation here is going to focus on your roadmap to the serverless cloud. And this would primarily be focused for people who are not using the serverless cloud already, but it might also be for people that are maybe stumbling a little bit with the serverless cloud. So you might be getting really excited about, you know, the demo that I just showed and all the benefits that I talked about earlier, and it really is exciting. So you might be thinking about, you know, reliability and performance and security and operational excellence and return on investment that you can get, but you really need to think about your migration path to the serverless cloud. And that's where I want to focus on for the rest of the presentation here for the last 5 or so minutes, and enabling you to have a successful migration to the serverless cloud. So I want to enable your path to the serverless cloud while thinking about the best approach to get you there, because there's a couple approaches. And you know the use case and benefits at this point. So let's think about how you can most effectively move to the serverless cloud. And I strongly believe it's not the technology that's going to let you down. I think you can be successful with basically any technology. It's your plan and design and your usage of that tool that can succeed or fail. And so some serverless cloud migration trajectories. There's a few paths that businesses can take along their way to the serverless cloud. And number one would be a custom cloud strategy. And this is one where integrations are custom built using AWS services directly in the AWS cloud. And this strategy gives you the most capability and flexibility, but it also requires the most amount of initial investment. So you just have to weigh that with your business. Are you willing to sink in that upfront cost to get the most flexibility and lower ongoing cost in the future? Another approach is a hybrid approach we talked about a little bit earlier. This is a great approach to enablement in the serverless cloud because you can combine strengths of iPaaS, for example, with serverless, and you can use the right tool for the job, and you can start to dissect your current system for the best use cases to move iteratively to the cloud, and only choose the right candidates to move to the serverless cloud. So a lot of times a really great approach. And then of course, wait and revisit is always an option. Sometimes doing nothing is the right answer. And in cases where there might be multiple business drivers that are in conflict or your path is unclear, sometimes the best option is to analyze your existing infrastructure and integrations and begin planning for the future, but really delay execution until the business drivers are more clear. And I think hybrid is so important that I created an additional slide, just to talk about hybrid, because really no matter your path, you're going to see some form of hybrid along the way. Hybrid is almost a given, and your hybrid, if you're using an identity provider with your API management, you're using hybrid approach. If you combine MuleSoft with AWS, you're using hybrid if you're using a transformation tool that's different from your routing logic, and so on and so forth. So really, regardless of your approach, at some point, you'll need to support more than one technology to enable your integrations. So planning for this is very important. And again, a lot of times I would actually support this decision. It's not an all or nothing in the serverless cloud, right? You have to use the right tools for the job. And so the quickest and best way to get to the serverless cloud is through decomposing your legacy or on-prem or iPaaS solution into the components that are the best candidates to move to the cloud. So if you're looking to move to the serverless cloud, this is the one takeaway I would send you home with. And that's to identify those right components for the serverless cloud based on your current implementation and move just those right components to the serverless cloud. And that's why your planning phase is so critical, where you can slice your system up based on two dimensions. One could be system components and one could be processes. So the system components that might be best to move to the serverless cloud, maybe are the ones where you need to absorb a lot of workload. Or the processes maybe that you move to the serverless cloud might be at first your low priority, low impact processes, for example. And your bridge to the cloud, I would urge, is iterative success. Again, it's not all or nothing. You might take this hybrid approach to deliver that iterative success. And that's exactly what we suggest many times here at Big Compass. It works really well. And so how do you actually accomplish this in practice in the real world? And I don't think it's a magic trick or marketing scheme or anything like that. It's just based on experience and what we've seen be successful. And we want you to be successful if you choose to take this path, because I truly believe that you can take this path if you choose to do so. And so number one, you would inventory processes. This would be part of your planning phase. And why that planning phase is so crucial, because you would inventory your processes in your system and identify those right candidates for the serverless cloud. And then you would use this second step as a checkpoint. And you would use this checkpoint to say, okay, do I actually have serverless cloud candidates to move? And if you do, and you decide with your business stakeholders that it makes sense to move those to the serverless cloud, then you can move on. If not, maybe you bail out, and you bail out early, and then you don't have too much risk and too much sunken cost. But most times you probably will. And then you can prioritize your serverless candidates. And that's where you can use that inventory from the first step to create maybe my top 1 to 3 priority serverless candidates that I want to move to the cloud first. And then you can focus on everything else behind those top 1 to 3 priority serverless candidates. And then from there, it's really a typical service development lifecycle. You would plan and design your serverless implementation as well as your migration. you would go through your implementation phase and you would run the workload. And now you are in the serverless cloud, ta-da. But really, the rest of this on the bottom side of the screen here is part of a good service development lifecycle. And if you have a good service development lifecycle, we believe with the right talent and the right processes, you can implement a good serverless integration solution. So what I would do as a part of this presentation, and maybe I'll hear from you guys at the next All Things Integration meetup, is I would challenge you to try to become operational in the serverless cloud in 30 days or less if you're not already. And what you can do is you can use this approach where you can iterate and fail fast. And what that allows you to do is adopt a serverless cloud quickly and for pretty minimal expense, because you can take those good serverless candidates, maybe that you've been wanting to move, try to prove a solution, maybe it's in a POC type fashion, and move them to the serverless cloud and just see if they work for you. Maybe run some QA traffic through there. If you're ambitious, maybe you can get it all the way to production in 30 days or less. And this type of approach will allow your business to test the waters with minimal risk. So I strongly believe in this approach. And again, I would throw that challenge out to you. And I will say the Salesforce.com syncing demo that we stood up today was probably operational in the cloud in about 30 days, maybe a little bit less. So, that's the type of complexity that we're talking about when you have, some dedication to serverless. And granted, we already had some expertise with serverless, which helped, us accelerate that timeline. But I'll bet that you can do this, and would love to hear from you, like I said, at the next meetup, about any success stories that you have. And if you ever need any help, feel free to reach out. Like I've said a couple times, happy to help with any serverless integrations, just talk about serverless, talk about iPaaS, talk about legacy, anything along those lines, happy to help out. I personally really enjoyed this. I'm glad to see some people out there with similar interests and integrations. And we're going to look to run this meetup about once every month. So look for that next meetup topic that Stephanie will be posting. And I hope to see you all next time.